In the silent expanse of cosmic space, a lone planet orbits a sun-like star, located 640 light-years from Earth. Known as Kepler 22b, it first made headlines in 2011 as a potential twin of our world, the first confirmed planet with a star's habitable zone where liquid water may exist. However, its story may hold more than just the promise of another Earth. What if this distant sphere conceals secrets far beyond our imagination? Could it be a cradle of alien life, a mystery shrouded in an ocean, or a silent observer in the darkness? The journey to uncover the mystery of Kepler 22b begins. So what do we already know about this planet? Kepler 22b orbits its star in approximately 290 days, a year not much shorter than our own. Its orbit is conveniently positioned in the Goldilocks zone, where temperatures are neither too hot nor too cold for liquid water to exist. The planet itself is about twice the size of Earth. Such planets are typically called super-Earths or mini-Neptunes with an unknown terrain. It has an atmosphere and clouds, as scientists suggest. Kepler 22b could boast a mild climate. Standing on its surface, one might feel as though it were a pleasant spring day on Earth. Early estimates suggest an average surface temperature of about 72 degrees Fahrenheit. Above us, a pale sun. Its parent star, Kepler 22, and very similar to our own, though slightly smaller and cooler. Since the planet orbits a little closer than Earth does to the Sun, it receives roughly the same amount of heat. Without a thick atmosphere, its planetary equilibrium temperature would be just above freezing, about 43 degrees Fahrenheit. However, if Kepler 22b has greenhouse gases similar to Earth's, this heat could rise to long-sleeve shirt weather. Theoretically, its conditions could rival or even surpass Earth's in terms of habitability. Lush clouds, stable temperatures, and gentle sunlight could adorn this distant world. Yet the true nature of the planet remains hidden. Is it a rocky paradise, a mini gas giant, or something even more exotic? Scientists can only speculate based on its size and orbit. Its mass and surface composition remain unknown, leaving room for speculation. One thing is clear: a solid Earth-like surface is unlikely. Kepler 22b is probably too light for its large size to be purely rocky. Instead, many researchers suggest this world may be covered by a vast ocean, earning it the nickname Waterworld. If so, the planet may conceal its secrets beneath endless waves, a global ocean stretching across its entire surface. And where there is an ocean, life may follow. Let's imagine Kepler 22b as an ocean planet, where no continents exist and perhaps only scattered islands break the surface. By day and night, its waters would shimmer with the reflection of its sun. Below the surface, an unfathomably deep ocean might extend hundreds of kilometers down, far deeper than the Earth's seas. The pressure in its abyssal depths would be immense. But just as in our own deep oceans, life might find a way. If Kepler 22b is mostly ocean, could an alien biosphere thrive in its waters? Astrobiologists take this question seriously. Natalie Batalha, a scientist on NASA's Kepler mission, has suggested that if it is mostly ocean with a small rocky core, it's not beyond the realm of possibility that life could exist in such an ocean. On Earth, our oceans teem with life. from sunlit shallows to the dark abyssal plains. Around deep-sea hydrothermal vents, hot, chemically rich springs on the seafloor, organisms flourish without sunlight, drawing energy from the planet's internal heat. If Kepler 22b has underwater volcanoes or hydrothermal vents, alien microbes could similarly survive on chemical energy. Over billions of years, evolution could shape complex life forms, strange fish-like creatures, massive jellyfish analogs, or forests of tube-like organisms swaying in the currents. Perhaps in the sheltered shallows or geothermal oases, life could take root and diversify. But could intelligent life arise in an ocean world? That remains a profound mystery. Any water-dwelling civilization would face challenges unknown to land dwellers. Underwater, there's no simple way to make fire or forge metal. As Bill Barucki from NASA's Ames Research notes, life in a global ocean would not have free access to electricity or fire for metallurgy. Humanity's technological journey began with fire, for cooking, crafting tools, and smelting ores. In a vast ocean, an intelligent species might never encounter land necessary to ignite a flame. Without fire, there could be no Bronze Age, no Iron Age, and perhaps no radios or rockets. This wouldn't make intelligence impossible, but it could slow technological progress. One could imagine that intelligent ocean dwellers might find an alternative way, perhaps using geothermal heat on the seafloor or bioengineered materials from their environment. Still, their tools and inventions would likely differ drastically from ours. If somewhere in Kepler 22b's global sea floats an intelligent species, what might they be like? Without fire, would they record their history in coral and stone? Could they develop writing, science, or astronomy while gazing at the stars from beneath the water? These questions blur the line between science and speculation, yet given the potential for life, one cannot dismiss the possibility that the planet's unfathomable depths may hold living secrets. Perhaps even an intelligence that looks up at its sky, wondering if it's alone. And yet, how can we detect life on such a distant world? Our telescopes observe the star Kepler 22 and detect a slight dimming when the planet passes in front of it. From this, we gather basic information: its orbit, size, and possibly a hint of its atmospheric composition. Scientists search for biosignatures, signs of life's presence such as oxygen and methane, which life on Earth releases into our air. However, alien life may not emit the signals we expect. What if life on Kepler 22b has left traces that we don't even know how to look for? Our current strategies focus on life as we know it. We scan exoplanet atmospheres for gases like oxygen, ozone, and methane, molecules associated with biology on Earth. However, not all life must resemble Earth's biochemistry. Scientists warn that by fixating on familiar markers, we risk missing the truly alien. Life, but not as we know it, might produce exotic gases or none at all. Imagine organisms that breathe something other than oxygen, or ecosystems where photosynthesis has been replaced by entirely different chemistry. The environment of Kepler 22b, with potentially high-pressure oceanic layers and possibly thick cloud cover, could support biospheres that are chemically enigmatic. A thriving ocean teeming with microbial life might leave subtle atmospheric hints, perhaps an unusual sulfur compound mix or an unexpected seawater chemistry, but nothing that would make our instruments scream life. To address this, researchers are developing the concept of agnostic biosignatures, a sign of life that does not assume a specific biology. Instead of searching for a particular gas, they look for patterns or complexities in atmospheric data unlikely to arise naturally. For example, an intricate blend of organic molecules or an imbalance in atmospheric chemistry could hint at metabolic processes. However, this is a complex challenge. Alien biology might be hiding in plain sight, its signals mistaken for geological or abiotic phenomena because we lack the context to interpret them. Our search is inherently anthropocentric. We look for life that mirrors our own experience. But a world like Kepler 22b forces us to broaden our perspective. It asks, if an alien oceanic world is brimming with life, will we recognize its signs? Or will its biosphere be a mystery, leaving traces we've yet to decipher? While astronomers study the physical properties of the exoplanet, others listen for whispers coming from its direction. Projects like SETI, Search for Extraterrestrial Intelligence, have aimed radio telescopes at its star, hoping to find an artificial signal amid the cosmic noise. After its discovery, Kepler 22b quickly became a prime candidate in the search for alien messages. So far, the void remains silent. No beacon signal, no interstellar greeting. But silence does not mean absence. It may mean we're listening for the wrong thing. What if an alien civilization does not use radio at all? Our own communication methods have evolved from simple radio broadcasts to fiber optics and highly focused beams. An extraterrestrial society may have moved on to technologies that we cannot yet conceive. They might use laser pulse to transmit data across the galaxy, or even neutrino beams, which pass unnoticed through matter. Perhaps the galaxy is filled with extraterrestrial signals that we lack the means to detect. Advanced beings might use quantum communication, sending entangled photons across space to whisper securely between stars. Such quantum signals or exotic particles would be indistinguishable from background noise to a traditional radio telescope. In essence, we may be listening to the cosmic conversation on the wrong channel. There's also the unsettling possibility that the civilization of Kepler 22b has chosen not to transmit at all. They might observe radio silence out of caution, or a principle of non-interference. Some theorists even propose that advanced societies may practice passive observation, quietly watching developing civilizations like ours without revealing themselves. If this intelligence has existed longer than humanity, it could have noticed Earth's faint atmospheric traces, subtle hints of oxygen, or even our earliest radio emissions through our signals that have yet to travel 640 light years. Perhaps they have the patience to simply listen, waiting for us to reach out. And so in this cosmic radio silence, we're left to wonder, is there truly no one out there? Or is someone listening in a language we have yet to decode? Enrico Fermi famously asked, "Where is everybody?" The Fermi paradox highlights the contradiction between the high probability of life in the universe and the lack of evidence for its existence. Could oceanic worlds like Kepler 22b be part of the answer? Perhaps the galaxy is rich with life, but most of it resides underwater, hidden from view, and it rarely ventures into space. Research suggests that truly Earth-like environments with stable continents, oceans, and plate tectonics might be rare. And if so, many habitable planets that may be water-rich spheres that foster life in their seas but seldom produce star-faring civilizations. Life could thrive in these oceans for ages, intelligent or not, content in its blue refuge and invisible to outside observers. Perhaps advanced civilizations are far less frequent than simple life. Kepler 22b might host life forms that never developed technology due to environmental constraints. From our perspective, a planet like that would be a reservoir of life, a living world that keeps to itself. If many advanced aliens are unable to escape their aquatic homes, this could explain much about the Great Silence, that space might be teeming with biospheres, each isolated like islands separated by a vast cosmic ocean. Another possibility is more provocative. Some advanced civilizations may choose isolation. Suppose a spacefaring species decides that secrecy is its best protection. This idea is sometimes called the dark forest hypothesis. They might live quietly, minimizing detectable signatures to avoid unwanted attention. An oceanic planet provides natural cover. A civilization could hide its cities beneath miles of water, its emissions and signals absorbed by the sea. Kepler 22b could be one such sanctuary, a place where an ancient species survives in the depths, unseen and unbothered. Perhaps they've witnessed cosmic dangers, wars, predators, or simply the chaos of the galaxy, and they've chosen to retreat into their paradise. It must be emphasized that there's no evidence of an advanced race or even life on Kepler 22b. However, the planet remains an intriguing candidate. With its stable orbit, potential oceans, and billions of years of history, Kepler 22b could be one of the great keepers of life in the galaxy, whether that life consists of humble microbes or something far more complex. Let's imagine that one day we confirm it. Kepler 22b is alive, possibly even home to an intelligent aquatic species. This realization would be both thrilling and terrifying. Are we ready for a first contact? Meeting an alien civilization would be challenging under any circumstances, but encountering one that evolved in an oceanic environment adds extra layers of complexity. The first obstacle we would face is communication. How would we talk to those beings that perceive the world through sonar clicks or bioluminescent flashes in the water? On Earth, we've spent decades attempting to communicate with dolphins, who are highly intelligent marine mammals, with only limited success. Aquatic aliens may think in ways that we've never encountered. Their language might be patterns of pressure waves or chemical signals in the sea. Even the very concept of verbal or visual symbols may be utterly foreign to us. Establishing a common language, perhaps through mathematics or simple imagery, could take immense time and patience. Not to mention diplomacy, which across such a divide would require creativity, empathy, and possibly technology to bridge our vastly different biospheres. Technology possesses another dilemma. If intelligent life on Kepler 22b never developed metal tools or electronics in that ocean, they might lack radio transmitters or spacecraft. So in that case, first contact might not come through messages or visits, but through our own explorations. Perhaps we'll be the ones to reach their world first. Imagine arriving at a planet covered by a global ocean, knowing that a sentient culture lies beneath its surface. How would we say hello? Drop a probe in the water, flash lights, or send sound pulses into the depths? Every approach could be misunderstood or even go unnoticed by a species that evolved in a completely different context. There is also a profound existential question of readiness. Humanity would have to grapple not only with the realization that we're not alone, but that our cosmic neighbors are entirely unlike us. Would we perceive intelligent aquatic beings as equals, despite their alien form and environment? Could we overcome our instinctive fear of the unknown and establish trust? Our history is full of misunderstandings, even between human cultures, and with aliens, the stakes and uncertainty would be even greater. Yet the very strangeness that separates us might also inspire us. As we prepare for such a possibility, we must ask ourselves, are we, as a species, mature enough to meet others without prejudice and panic? Kepler 22b beckons with its mysteries, yet it lies at an almost unimaginable distance. At roughly 640 light-years away, it would take centuries, if not millennia, to reach with any technology we can currently envision. Using a conventional spacecraft like the one that took astronauts to the moon, that journey would last millions of years. Even our fastest unmanned probes would take tens of millions of years to bridge the gap. Clearly, new methods of interstellar travel are necessary if we hope to visit this world. Scientists and engineers have proposed several theoretical solutions. One is the idea called the light sail, a spacecraft propelled by powerful laser beams or sunlight. Projects like Breakthrough Starshot propose sending those tiny probes attached to light sails at speeds of up to 20% of the speed of light. At that speed, the trip to Alpha Centauri, 4.3 light-years away, would take 20 years. However, Kepler 22b is 150 times farther. A Starshot-style probe would still take about 3,000 years to get there. A human crew would require a different approach. Generation ships, a classic science fiction concept, are massive vessels where crews live, reproduce, and die over many generations during a journey that could last centuries. A colony of humans could slowly cross the stars, with distant descendants eventually arriving at Kepler 22b, knowing no life other than the ship. The engineering and social challenges of this kind of project would be staggering. We're essentially talking about the creation of a self-sustaining world ship. Nonetheless, it remains one of the more plausible ways to settle distant systems with near-future technology. Even more speculative are concepts like warp drives and wormholes. A warp drive, in theory, would bend space-time, allowing a spaceship to ride a wave, effectively shortening the distance. Now, in theory, this could enable faster-than-light travel without breaking physics, but it would require exotic forms of energy and matter whose existence remains uncertain. Wormholes, hypothetical tunnels in space-time, could instantly connect two distant points, If a naturally occurring wormhole existed near Kepler 22b, or if an advanced civilization had built one, the journey would become trivial. Step through, and you're there. However, wormholes remain purely theoretical constructs, unproven and likely unstable even if they do exist. While those ideas spark the imagination, the reality is that interstellar travel remains an engineering puzzle yet to be solved. Every proposed method faces enormous technical and energy challenges. Yet human ambition has a way of turning today's impossibilities into tomorrow's achievements. Not long ago, reaching the moon seemed like science fiction. If Kepler 22b continues to intrigue us, if we find hints of life or other compelling data, it may become a goal that drives us to a new breakthrough. Perhaps we can develop propulsion systems capable of sustaining speeds far beyond what we currently consider possible, or advanced hibernation technology that would allow a crew to sleep for millennia. To reach Kepler 22b is to reach into the future. It will require patience, innovation, and perhaps a new kind of journey. One where those who depart are not the ones who arrive. Whether through robotic probes or one day human explorers, the allure of this distant world may ultimately push us towards the stars.